understand about a project called as optimization of material mix and power consumption. So let's imagine a steel manufacturing company that makes thousands of tons of steel every day. For such a company, consistency in product quality is very important, but often due to variability in raw materials and power usage, they face issues in producing consistent, high quality steel. Our client is one of the leading manufacturing companies. So let us understand what is the problem they are facing. The company is facing challenges in consistently producing high quality grades of products due to variability in material mix and power consumption. These inconsistencies lead to fluctuating product quality, increased production costs, and inefficiencies in manufacturing process. The company needs to identify the optimal combination of material mix and power consumption to ensure consistent product quality. Variation in material mix, like types and quantities of raw materials and power usage, are making it hard to maintain product quality. So, what are the impacts of this? Quality goes up and down, cost increases due to inefficiencies, processes become unpredictable, right? Think of cooking your favorite dish. If you keep changing the ingredients slightly or use different stove heat every time, the taste will vary. Manufacturing is similar. Consistency is the key. So let us understand business objective. Minimize cost and maximize quality. That is, reducing the cost, we need to improve the quality. And the business constraint speaks about minimize energy usage. Ultimately, we need to use less energy. Now let us speak about success criteria. Ultimately, we need to help the business to reduce processing time by 20%. And economic success criteria speaks about achieving a cost saving of at least $1 million. That means we need to save at least $1 million of the company. These targets help the company measure whether the optimization strategies are really working or not. So this is the process. This is the visual process how the steel manufacturing happens. Iron ore is and coke is taken into the pellet plant. It is then being taken to blast furnace, and then a steel will come out of the steel, liquid steel will come out of the blast furnace, and then after reheating, you will be getting the final product. Let me walk you through the model architecture, how the solution looks like. This is where we will see how the overall process happens. First would be the data collection. We need to understand what are the multiple sources from where we can collect the data. Okay, whether it could be machines, whether it could be sensors, Excel files, databases, etc. In factories, data is everywhere in sensors, temperature logs, power meters, and material usage reports. So what are this primary source? Directly from the factory machine, if you're taking the data, that data is called as a primary data. Secondary data source, stored historical data, files, databases. Now, once you collect the data, you need to store the data somewhere. That we call it as data storage. Loading the data into MySQL or any other databases. Once you load the data, we need to clean the raw data. You might have duplicates in the data, you might have missing values in the data, or any other complexity in the data. We need to reduce this complexity. We will analyze the data. That is, we will do exploratory data analysis. This is like getting to know your data, finding missing values, outliers, and patterns out of it. Then comes your cleansing, fixing data issues to prepare it for the analysis. For this, we might use pandas and numpy for cleaning and pre-processing. Matplotlib and seaborn could be used for the visualization purpose. So these tools help us see patterns like how one material mix leads to more waste or higher power use. So based on the visualization, based on the analysis, a decision is made. Once insights are ready, management uses them to make better decisions. For example, if we see that using more of material A reduces energy by 10%, that becomes part of the new strategy. Let me walk you through the dashboard as well. So, this dashboard is like the control panel of a smart car. It tells us everything about how the manufacturing process is going. So production dashboard. This is more about production dashboard. So we can see total energy consumed in kilowatt per hour, total production in metric ton, gross wastage, wasted materials during production, total charge, raw material input for furnace, and then few visuals, that is pie chart, total production versus wastage. This gives a quick overview of how much material is getting wasted, a direct measure of efficiency. Bar chart, top 10 steel grades produced. This helps us to identify which grades are produced most and how much scrap is associated with them. Over here, we could see total melting time, total turnaround time, the time taken from start to finish, and the bar chart. Top 10 grades with less melting time. This helps optimize which grades are faster to produce, saving energy and time. Chemical composition pie chart. Chemical analysis helps us maintain consistency. Too much variation here affects quality. So this is something about the dashboard where we can analyze more about the data. So this project combines data engineering, data analysis, and business decision making to solve a real world problem. How to improve quality, reduce cost, and save energy in manufacturing. So in 360, what do we offer? Challenging real-time projects that push you to your limits, learning of all phases of project methodology, learning about different tools used in the industry like Python, Power BI, cloud platforms, etc. Work on research papers that are published in international journals, access to various free tools to enhance your learning like Mind Map, ML Architecture Assistant, Resume Optimization Hub, and Animated Learning. You must be wondering now, who is the person who's speaking for such a long time? Well, my name is AiSPRY. I work as an associate data scientist at AiSPRY. Thank you.